The University of Idaho has a lot of vending machines on campus. We can divide these vending machines into three categories. Ones that need to be on all the time, like ones in residence halls. Ones that need to be on only during business and class hours. And then vending machines that need to be on during business hours, but also on the weekends, like in laboratories. There are two different kinds of loads in any given vending machine: lights and refrigeration. Some vending machines don't require refrigeration because the snacks inside don't have to stay cold. But if there's drinks, you want to keep them chilled. A way to decrease the load of vending machines that require refrigeration is called a plug-through device. The vending machine is plugged into a device that can have something like a timer, and then that is plugged into the wall. One common device that you'd know of that works this way is a Christmas light timer. There are devices on the market, such as one called a vending miser, that goes beyond just a simple timer and uses a more complex and programmable timer, and also proximity sensors. So you have two solutions. A timer can decide when the machine will automatically turn on and off, and then a proximity sensor can detect when a potential customer comes near and the machine will turn on. There is one problem with this. A customer expects their drink to be chilled, so it can't just come on when a person approaches it. It already has to have been on for the drink to be chilled. As engineers, we can imagine a very easy solution to this: a temperature sensor. If a threshold temperature is exceeded, the refrigeration will simply turn back on. However, this is an issue because we don't have the ability to tamper with these machines. There are vending machines of the future that'll be more efficient than the ones we have right now, but our mandate is to work with the ones we've got and to make them as efficient as possible. So now we have a few questions to ask. What's a maximum temperature that we want beverages to be at throughout the day? So if you expect your first customer at 8 a.m., what time in the morning do you want your vending machine to turn on automatically to get that beverage cooled down for them? If you can divide the day into an off period during the night when you don't expect a customer, and an on period during the day when you do expect customers. During the on period, how often should the machine turn on automatically? And if a proximity sensor doesn't detect anyone, how soon should it turn off? These questions require analysis and observation, and ultimately could be customized to any given vending machine depending on its scenario and its placement. Mark Compton, a utilities engineer on campus at University of Idaho, estimates that 10% of the vending machines on campus use vending misers. In the year 2000, John Rigger and Joel Huggins at Texas A&M University did a very thorough study specifically to evaluate vending miser devices. This study looked only at vending machines on Texas A&M campus, which represent the same vending machines found many other places in America. With vending misers installed, each individual machine saved $64 in energy cost per year, offering a payback period of 2.6 years, such that the vending misers paid for themselves. Common vending machine brands typically found in America include Dixie Narco and Royal. Common refrigerant types include R12 and R134. Ritter and Huggins make clear that vending machines in continually occupied areas such as residence halls should not use vending misers. In 2003, the National Renewable Energy Laboratory produced an excellent study. The NREL's study examined the amount of energy that could be saved by both delamping vending machines and from using plug-through load managing devices. A load managing device completely cuts power to the vending machine. This is essentially the same as unplugging it, plugging it back in, unplugging it back in, many times throughout the day. The NREL points out that this does not damage vending machine components. Specifically, it actually saves the compressor, which has a limited number of cycles for a vending machine's lifetime. Each vending machine consumes on average 8.3 kilowatt hours per day of energy. Using a load manager based on passive infrared motion sensing technology, this baseline value was reduced to 5.6 kilowatt hours per day. Using both a load manager and delamping the vending machine, the total energy usage was reduced to 3.7 kilowatt hours per day. That is a savings of 56% of energy usage. The estimated minimum amount of energy savings from simply delamping any vending machine is 27%, without buying any extra parts or equipment. It is important to contact the contractor that provides your vending machines before pursuing a delamping operation. A 2016 study from the University of Guanajuato in Mexico states that behind photocopiers, vending machines use more electricity than any other electrical device typically found in universities. This study stakes vending machines at loads between 350 watts and 700 watts, with photocopiers exceeding that from 120 watts to 1100 watts. Compared to all other electrical devices at the University of Guanajuato, vending machines have the most on time of 8 to 10 hours. It is important to note that there are cultural differences around the world, meaning that vending machine designs and applications will also differ. An excellent example of this is a coffee vending machine, which we don't see very often at all in the United States, but are very common in Latin countries. Outside of the vending miser, which is a complete and easy solution that's already here in use at the University of Idaho, there are also some other interesting solutions, specifically in regards to observation. Shajahan and Anand at Anand University in Chennai, India, have developed an Arduino-Android platform for a smart plug-through device. This device allows for continuous remote monitoring of energy consumption for any given plug device. Michael Lorig at UC Berkeley wrote his 2015 dissertation on wireless power monitoring at both plugs and panels. His panel-based device is focused on using Hall effect sensors to collect amperage readings from each circuit breaker within a panel. Today we have covered quite a lot of information about vending machines, the loads that they have, and how to minimize the energy used to support a vending machine. We talked about a simple solution, like a vending miser, and also more complex custom observation techniques going on at higher education and research institutions. Thank you very much to the University of Idaho Library for helping me to find all of these amazing resources.